Materials. In particular, the development of high-K dielectric materials, which have a higher dielectric constant than traditional materials, has been an active area of research in recent years. These materials are used to create capacitors in LEDs, which help to improve their efficiency and reduce power consumption. Waste management. The production of LED lights can generate a significant amount of waste, including unused precursor materials and byproducts from the production process. Inorganic chemists are involved in the development of waste management processes, such as recycling or disposal methods, to minimize the environmental impact of LED production. One example of a waste management process is the recycling of indium, which is a rare and expensive element used in the production of certain types of LEDs. Inorganic chemists are involved in the development of processes to recover indium from waste materials and reuse it in the production process. Challenges and future directions. While inorganic chemistry has contributed significantly to the development of LED technology, there are still several challenges and areas for improvement in the field. One major challenge is the limited availability of certain elements, such as indium and gallium, which are essential components of many types of LEDs. Inorganic chemists are exploring the use of alternative materials that are more abundant and cost-effective, such as zinc oxide and copper-based compounds. Another challenge is the high cost and complexity of the LED production process. Inorganic chemists are actively researching ways to improve the efficiency and scalability of LED production, such as the use of new growth techniques and process optimization. In addition, there is a need for continued research and development of new phosphors and encapsulation materials with improved properties, such as higher efficiency and longer lifespan. Looking to the future, inorganic chemistry is poised to play an even greater role in the development of LED technology. One area of research is the development of quantum dot LEDs, which use nanoscale semiconductor particles to emit light. Inorganic chemists are involved in the synthesis and characterization of these materials, as well as the development of new methods for their integration into LED devices. Another area of research is the development of flexible and transparent LEDs, which have the potential for use in a wide range of applications, including wearable devices and displays. Inorganic chemists are involved in the development of new materials and processes to enable the production of these devices. Tiek tuc va kong trung lap. In addition to the challenges and areas for improvement, there are also exciting developments in the field of inorganic chemistry for LED production. One such development is the use of perovskite materials as a potential alternative to traditional semiconductor materials. Perovskites are a class of materials with a unique crystal structure that exhibit excellent optoelectronic properties. Inorganic chemists are exploring the use of perovskite materials in LED production due to their high efficiency, low cost, and ease of processing. Another area of research is the use of nanotechnology in LED production. Inorganic chemists are involved in the development of new nanomaterials with unique properties, such as enhanced light emission and improved stability, for use in LEDs. Furthermore, inorganic chemistry is also important in the development of advanced lighting technologies beyond LEDs. For example, inorganic chemists are involved in the development of electroluminescent materials for use in organic light-emitting diodes, OLEDs, which have the potential for use in high-resolution displays and lighting applications. Inorganic chemists are also involved in the development of phosphorescent materials for use in phosphorescent organic light-emitting diodes, PHLEDs, which have higher efficiency and longer lifespan than traditional OLEDs. In addition to the development of new materials and processes, inorganic chemistry is also important in the characterization and analysis of lead materials.